My name is Dave Cranage, Field Sales Engineer for Sage X3 here in North America, and thanks for joining me for this session. This session is a follow-up to our initial overview video of Sage X3's web scheduling. This session will build on several concepts introduced in the web scheduling overview video. If you haven't watched the initial web scheduling overview session, please go back and review that session before continuing. In this session, I hope to introduce several web scheduling concepts. I want to discuss the concept of infinite and finite capacity and the value each has on production planning and scheduling. I want to review X3's Work Center configuration that defines a resource's available capacity. I want to examine X3's routing, operation, and scheduling settings of a product and how that dictates the production plan of a work order. And finally, I want to demonstrate how the Work Center configuration and a work order's production plan define and utilize the finite capacity of resources within web scheduling. To start our discussion today, let's review the two main concepts used in manufacturing planning and scheduling to define an enterprise's resource availability: infinite and finite capacity. To start, we need to first understand the concept of the infinite capacity loading approach and how it is used in managing a schedule. An infinite capacity loading approach to planning and scheduling assumes that the due date of every order is absolute while ignoring the available resource capacity. In essence, we assume there are unlimited time and resources to produce something. Infinite capacity loading can be helpful to identify uneven workloads or to quickly change the work schedule to balance resource requirements. But because we are scheduling without considering existing work or commitments of the resources, we are at risk of capacity overload, unavailable resources, and overpromising on delivery dates. Infinite capacity scheduling is great for long-term horizon planning and capacity forecasting, but not for managing a real-time, dynamic, ever-changing, and constraint-riddled production schedule. With finite capacity planning and scheduling, we create a more realistic schedule for the production processes than the infinite loading approach. Finite capacity planning and scheduling takes into consideration the start and end times of each operation to ensure that the production schedule generated is realistic and feasible. If there is not enough capacity available on the resources, the planning and scheduling system will schedule the work on the next available capacity interval, if there is enough material available to start production at that time. The goal of finite capacity scheduling is to ensure that work proceeds at an even and efficient pace throughout the plant. Finite capacity scheduling is an excellent solution for short-term horizon strategic planning, perfect for managing a real-time, dynamic, ever-changing, and constraint-riddled production schedule. In summary, an infinite capacity loading approach assumes that the due date of every order is absolute while ignoring the available resource capacity. A finite capacity approach creates a more realistic schedule for the production processes than the infinite loading approach, by always respecting the available resources capacity as well as the order's due date. Before we head over to X3 and web scheduling, let's review the key elements necessary in defining and utilizing the finite capacity of resources within X3 and web scheduling. First, we'll take a look at X3 Work Center configuration to define our resources capacity, X3 product routing configuration to create an accurate work order production plan, and lastly, let's review some of the key web scheduling capabilities that make it such a dynamic scheduling solution. The X3 Work Center configuration is used to define the resources to be used for manufacturing operations within a product routing and as resources available within scheduling. A work center can be defined as a machine used in your manufacturing processes, a labor resource, or an operation in a routing that is subcontracted to an external supplier. Keys to defining a resource's available capacity are structure, or its shift pattern, the number of resources, a resource's percent efficiency, capacity variation, replacement or alternate resources, and the optimization matrix. The X3 routing configuration is used to define and sequence the manufacturing operations or processes required to produce or process a particular product. Each routing is associated with the stock item that is being made or processed. When a product's routing is applied to a work order based on a required quantity, X3 produces a production plan for that work order. Key to defining a work order's production plan are the routing and routing code, its site, the routing time unit, the routing operations and their related work centers, scheduling details, and indirectly the associated manufacturing BOM. Sage X3's web scheduling evaluates the existing finite capacity of physical, logical, and economic resources, and through automated production planning allows for the simulation of production needs and supply requests. It utilizes heuristics or rules to drive the scheduling algorithm. It prioritizes based on the ASAP rule, which has been determined to be the best for meeting required deadlines. It automatically selects the proper resources to be utilized, taking into consideration alternate resources and percent efficiency, and it optimizes and groups work orders dynamically. It also synchronizes work order operations based on upstream and downstream resource constraints, and it provides unlimited what-if scenarios critical for determining the most effective schedule. Let's head over to Sage X3 and see how this all comes together. From my homepage, let's jump over to X3's Work Center configuration, open in this second tab. Here you can see I've filtered my selection to only show work centers related to manufacturing stools, and have selected the stamping machine work center to look at. The work center configuration is where you define the production resources to be used for manufacturing operations within a product's routing, as well as what resources are available to web scheduling. Let's focus on the key attributes that impact a work center's available capacity. The work center structure represents a weekly shift pattern that defines the total available capacity. A structure can be common to multiple work centers or specific to an individual work center. The structure is used to build the calendar in web scheduling representing the work center's capacity. The number of resources determines how many identical or duplicate resources a work center has. This can be either labor, e.g. 3 employees available in packing, or machines, e.g. 2 stamping presses. The number of resources is used to tell web scheduling how many identical or parallel resources are available, expanding the overall available capacity for the work center. Percent efficiency makes it possible to adjust the standard times of the routing according to the typical performance of the work center resource. Using my selection for paint robots, we can view the percent efficiency of each. You'll see that my older paint robot at 75% is less efficient than my new paint robot at 100%. Web scheduling uses the percent efficiency to dynamically adjust the runtime when manually moving a task from an efficient work center to a less efficient alternative or replacement work center, or vice versa. Capacity variation represents non-available periods for the given work center, such as upgrades, maintenance, breakdowns, holidays, etc. Use the grid to define a work center's availability exceptions, which refines its finite capacity calendar in web scheduling. Reason codes may be assigned to capacity variations to classify the downtime. If we look at the painting robot 2, we can see a capacity variation on January 19th of next year for a full day of downtime on our one resource, and the reason code is software upgrade. The replacement work center is an alternate resource that can be substituted for the primary work center when the primary work center is overloaded or if we want to even out the load. In essence, it is a backup resource to the primary resource. Replacement work centers do not have to be exact replicas, but they must be able to be similar enough that they can perform the same functions. You also need to have separate work centers if you are going to take advantage of X3's setup matrix capabilities. Each work center, to be optimized, must be set up independently for optimization to work. Let's jump over to my third tab and review a product's routing configuration. Within the product, you can see I've filtered my selection again based on stools. I've also selected the SFI 026 standard stool legs raw product to review. As I mentioned earlier, the X3 routing configuration is used to define and sequence the manufacturing operations or processes required to make or produce a particular product. It is also what is referenced when a production plan is created for a new work order. It's the work order's production plan that the web scheduling uses to create the schedule. Let's drill into the product's routing and explore the key attributes that determine a product's accurate production plan. The routing, routing code, and site define the relationships and features of the product's routing. The time unit value, mins or hours, determines what will be used in the calculation of time for the routing. Let's jump down to the routing operations section. Here is where the plan is defined for the product. Each line within the table represents a production operation to be completed. I don't want to review every column in the table, but I do want to point out a couple key columns related to our session. The num column sets the operation sequence. The work center represents the resource to perform the operation. The number of resources defines the number of resources required to complete this operation. Scroll over a little bit. Setup time is the amount of time to prep or prepare the resource and get it ready to perform the operation. Runtime code, management unit, and base quantity set the parameters that will be used to determine the runtime. Runtime is the amount of time it takes to produce the base quantity. Rate is the number of units that can be produced in the base time unit, minutes or hours. Percent efficiency is the operation level override value specific to the product routing affecting the rate at which the operation will be performed. Jumping down further to the scheduling section, again, I only want to focus on 3 items here. Next opper is where we're really starting to see the sequencing take place, and it represents the next operation or the downstream process. Scheduling is a set of options that dictate the way operations will relate to each other within the schedule. We'll focus on 2 of the options. First, simple successor, which Positions is just after the previous operation. So in essence, operation 1 finishes, boom, operation 2 begins. As well as the 3 overlapping options. The next operations can start, when I'm using overlapping, the next operation can start based on a specific quantity being achieved, based on a number of lots being achieved, or a certain amount of time has been achieved or has taken place. There's certainly more to explore in the operations and scheduling tables, but we've covered what we needed to for today's topic. Let's head over to the third tab and look at a work order's production plan. Again, for the benefit of our session, I've filtered for only the work orders pertaining to stool products. The work order we're looking at is for the product we reviewed earlier, SFI 026, standard stool legs raw with a quantity of 10. Let's scroll down in the work order to the operations section. For all intents and purposes, this is our production plan for the specific work order. It was generated based on the routing configuration for our product. Each line in the table represents a process or operation to complete for the work order. Looking at the table, you can see several columns that are critical for defining the work order's schedule. The sequence number. Again, this is the rough order in which operations will be completed. The work centers and their descriptions are the resources required to produce our work order. The earliest start date, as defined by the receipt of a required raw material, is a scheduling constraint known as first date of material availability, or FDMA, and the time unit and associated times are the time factors, setup, run, etc., calculated to complete each operation. This production plan data, as well as our work center configuration, is communicated to web scheduling and becomes the basis for creating a schedule for this work order. Let's head over to web scheduling and check out the results. Let's enlarge web scheduling to a new tab and make a few adjustments to the screen. I've already had my user logged in, my resources locked, my master simulation selected, my scheduling horizon defined, and my site set. Remember, we want to see how work centers and routing configuration settings define web scheduling's finite capacity of resources and how work order production plans utilize that capacity. If we expand the resource tree, we can see the site, work group, and work centers that have been assigned to my user. Looking at the production Gantt, I notice the white and gray areas shown across time. This is the available white and non-available gray time as defined by the different work center structures. On the Paint Robot 2, if we scroll over to January 19th, we see the capacity variation we defined for the software upgrade. Remember, that was a full day of downtime. Web scheduling respects these modifications to the capacity. Selecting the tag shown on Robot 1 on January 19th, I immediately see that Robot 1 and Robot 2 turn blue. They are replacement or alternate resources. Blue lines indicate the tag's synchronized upstream and downstream dependencies or constraints. Sequencing comes from the work order's production plan. Looking at the resource column within the production Gantt, we also see the parallel machines. Remember that the par machine value represents the number of resources available for the work center. Web scheduling utilized the information from X3's work centers and routing configurations via the specific work order production plans and dynamically generated the simulated production schedule. The automated scheduling algorithm prioritized, optimized, and synchronized all the work orders while respecting each work center's finite capacity. Looking at the fishing pond, or the to-do list if you'd rather, we see all the work orders and their associated operations. This list can be made up of suggested planned or firm work orders. For our session, I have only brought in and scheduled firm work orders. Notice the sequence or phase, work centers, optimized setup time, and working time or runtime columns. Again, the results we see originated from our X3 configuration setups and the specific work order production plans. Finally, let's select the bending machine and go to the resource Gantt. Here, we see the specific capacity trend, or utilization of the work center's finite capacity. Web scheduling communicates to the scheduler what a resource's total finite capacity is, what has been used, and what is still available. It will even warn the scheduler when they exceed the capacity available when doing a manual edit of the schedule simulation. In summary, web scheduling evaluates the existing finite capacity of physical, logical, and economic resources, and through automated production planning allows for the simulation of production needs and supply requests. Let's head back to our presentation to wrap up our session. Just to wrap things up, remember that we first discussed capacity loading concepts and learned that infinite capacity loading can be helpful to identify uneven workloads or to quickly change the work schedule to balance resource requirements. It is beneficial for long-term capacity planning forecasting, and that finite capacity loading is a detailed scheduling strategy that considers the available capacity of a manufacturing facility's resources to schedule jobs and operations. It is beneficial for short-term strategic capacity planning and ensures that work proceeds at an even and efficient pace throughout the plant. We reviewed the different settings within X3's Work Center and product routing configurations and learned how they impact available capacity. We also learned how they help define a work order's production plan. Finally, we saw how the Work Center configuration and a work order's production plan define and utilize the finite capacity of resources within web scheduling. To close, the purpose of a dynamic finite scheduling system is to maximize production, increase throughput, improve on-time delivery, make customers happy, and in the end, make companies money. How does it do that? Here are some, but not all, the ways it does. Thanks for joining me for this session, and look for more interesting sessions regarding web scheduling to come.